Suppose that in the 2026 QAMT problem solving competition, you come across this problem. What are you going to do with that? So, a positive integer n is called lucky if the sum of the digits of n squared is equals to n. Find the largest lucky number. So, maybe we can try and narrow down the range of the numbers we are looking for here. So, I'm just going to write number of digits in n, okay? And how many digits would there be in n squared? And I want to take a look at the digit sum. What is the maximum digit sum of n squared? Okay, let's say we have one digit in n. A one-digit number is less than 10. When you square it, it's less than 100. So the number of digits is either 1 or 2. Think about it. 1 squared is 1. It's got one digit. 9 squared is 81. It's got two digits. What's the maximum digit sum of n squared? Well, there's no need to calculate, but just think about if there's at most two digits, the maximum digit sum is 2 times 9. The maximum digit sum is 80. We can keep going. If n has two digits, then n squared is going to have 3 or 4 digits. Of course, if n is less than 100, then n squared is less than 10,000, so not 5 digits. So there's not more than 4 digits in n squared. The maximum digit sum, in no way can the digit sum exceed 36, right? If n has 3 digits, then there's 5 or 6 digits in n squared. So the maximum digit sum is 6 times 9, 54. And 4 digits. You should be able to see the pattern here, right? The maximum digit sum is just increasing by 18 each time. So it's increasing quite slowly compared to n because I'm adding one digit to n each time. It's like multiplying n by 10. So you can see that already in this place, we're going to have issues because the maximum digit sum of n squared still only has two digits here. So the digit sum of n squared for any n with 3 or 4 digits, that's never going to be more than 2 digits. And you can see that n is growing a lot faster than the maximum digit sum of n squared. Because, of course, an exponential function, that's going to grow faster than a linear function. So we can see that all of this is not going to work. So that means n cannot have more than 2 digits. If n has 2 digits, then n squared can only have at most 4 digits. So the maximum digit sum of n squared is 36. So n cannot possibly be anything more than 36. N is 36, it's not going to work. It's going to be bigger than the digit sum of n squared. So n is less than or equal to 36. N squared is less than or equal to 36 squared, which I think is 1296. So now, can we say something about the digit sum of n squared? Something stronger than being less than or equal to 36. Well, if n squared has 4 digits, then the maximum digit sum is 1, something less than 1296. Consider 1199. That digit sum is only 20, right? That digit sum is only 20. And then, if it starts with a 1, 2, it's not going to get bigger than 1289 or something like that. That is also 20. So the digit sum of n squared cannot go past 20. That's because we have a heavy restriction on this first digit, has to be 1. Okay? So if the digit sum of n squared is less than 20, n cannot be anything more than 20. Now, n cannot be anything more than 20. We can see that n squared cannot be anything more than 400. And we can keep doing this argument to bound. Something less than 400, can we say that the digit sum of n squared, well, 399 is the biggest that we can get, right? 3 plus 9 plus 9. Well, I guess that is still 21. So maybe 999, we can get to 27 or something like that. So we can see that n is less than or equal to 27. With 999, it still works somehow, but n squared, that's going to be still less than 729. So at this point, we're able to test some numbers, right? So 9 squared is equal to 81, right? And 8 plus 1 is equal to 9. So 9 is lucky. We can test now. 10 squared, the sum of this digit is not 10. 11 squared, that doesn't work. 12 squared. 169, this is getting too big, right? 196, the sum of this is 16. Okay, I can keep testing. 16 squared, 256. 17 squared, 289. 8 plus 9 is 17. This is 19. 324, that's 9, not 18. 361, that doesn't work. 400. 441. I think we're never going to get anything big enough now. 484, that's 16. 529, that's not 23. 576, the sum is 18. 625, that's not 25. 676, the sum of these is 19. Okay, and since n cannot be anything more than 27, we can say that the largest lucky number is 9, because if n is greater than 27, then the digit sum of n squared has to be more than 27, which we've just proven doesn't work. So after testing, what, 18 different numbers, we can see that there's nothing more than 9 that's lucky. And we can see that 9 is lucky because the sum of 8 and 1 is equal to 9. So that means the largest lucky number is 9. And we are done.